Hello, Mr. Betts here. Let's take a look at a couple of straightforward examples using the quotient rule. So the first one, we can see that f of x is a quotient function because it is a function divided by a function. So when I'm doing this, I'm going to think of the top as high or u, the bottom as low. So if we're thinking of that little rhyme with the quotient rule, we're going to have the derivative is going to be low d high. So the bottom times the derivative of the top minus high d low over the square of what's below. So in this particular problem then, if we're thinking of the top as u and the bottom as v, we're going to have the derivative of f is equal to, so it's going to be low, which is sine of x, d high. So taking the derivative of a polynomial, we're going to have multiple terms, so I want to put that in parentheses. So the derivative of x cubed is 3x squared, plus the derivative of x, or 1x, is going to be 1. So that's low d high minus high d low. So high is going to be the top, x cubed plus x, no derivative there. D low, so derivative of sine is going to be cosine. And then over the square of what's below. So the bottom is sine of x, the derivative, no derivative, but we are going to take sine of x and square it. You can write it like that. Or with trig functions, there's a shortcut way of writing that. So we can say sine squared of x. Keep in mind, sine itself is not a number, so we can't square sine, but what this means is we're going to take the sine of x and then we're going to square it. No need to do any simplifying or anything like that. There's your answer. In this example, we're going to do the same thing. So we'll do low, which is x squared, d high, so the derivative of e to the x is e to the x, minus high, d low, derivative of x squared is 2x, and then over the square of what's below. So x squared squared is going to give us x to the fourth, and that's it. That's all you have to do.